In today's lesson, we'll be learning how to determine the x and y intercepts of quadratic relations. We learned how to determine the x and y intercepts of linear relations in a previous unit. The method is exactly the same. If you want to find the x-intercept, you sub y equals 0 and solve for x. Since you have the values of x and y, you have the coordinate of the x-intercept or intercepts. If you want to find the y-intercept, you sub x equals 0 and solve for y. That gives you the value of y and the value of x. Therefore, you have the coordinate of the y-intercept. In our first example, we want to determine the x-intercept of y equals x plus 2 multiplied by x minus 3. If you recall, this is a quadratic relation in factored form. If you had the graph of this quadratic relation, you could easily look at it and find the x-intercepts, that being -2 and +3. I'm just going to label these x-intercept, and that is also a x-intercept. Now, you'll notice something interesting. I just said the x-intercept was -2 and +3. And if you look closely at the factored form of this quadratic relation, you'll see that these numbers are very similar to our x-intercepts in the graph. However, the signs are different. Therefore, there must be some sort of mathematical way of figuring out the x-intercepts without graphing the actual parabola. Let's go ahead and do that. So we are going to begin by rewriting our equation, which is x plus 2 multiplied by x minus 3. If you want to find the x-intercept, you're going to sub y equals 0. I'm going to write that down here. Sub y equals 0. That means you're going to replace the variable of y with the number of 0. And you can put that in brackets if you want. I'm not going to. And everything else stays exactly the same. As you can see, we have two binomials, x plus 2 and x minus 3. When you multiply them together, you're going to get an answer of 0. That means either x plus 2 is equal to 0, or x minus 3 is equal to 0. If you don't understand what this means, you can always ask me about this in class. What we're going to do next is we're going to solve for x in both of these equations. Now, you're going to rearrange these equations like you've done multiple times. So, if I want to isolate x, I need to get rid of this +2. The opposite of +2 is -2. Therefore, I'm going to subtract 2 from both sides of the equation. These 2's are going to cancel out, which leaves me with x equals 0 subtract 2, which is just -2. Next, I'm going to do the exact same thing with the other binomial. So I want to isolate x, but it is stuck with this -3. The opposite of -3 is +3. So we're going to add 3 to both sides of the equation. The 3's are going to cancel out, and we're left with x is equal to 0 plus 3, which is just +3. I'm not going to write the positive sign in. And as you can see, that makes our x-intercepts -2 and +3, and we already determined that by looking at our graph. In the second part of example 1, we want to determine the y-intercept of the same quadratic relation. If you've been given the graph, you can just look at the graph and determine it, and you can see that the y-intercept is -6. But there must be some mathematical way of doing this if we're not given the graph, and there is. Let's begin by rewriting our question, which is y equals x plus 2 multiplied by x minus 3. We've discussed previously, to find the y-intercept, you're going to sub x is equal to 0, which means you're going to replace all of the x's with a 0 in brackets. Now, I don't really need the brackets here, so I'm just going to not use them. And this is what you get. At this point, you need to simplify what you have in the brackets first, because you want to use BEDMAS. So 0 plus 2 is just 2. I'm going to remove the positive sign. And 0 minus 3 is just negative 3. And what you have here is multiplication, since there is no sign in between these brackets. So positive 2 multiplied by negative 3 is negative 6. And we already determined that our y-intercept was negative 6 by looking at the graph. Therefore, we can conclude we didn't make a mistake in this question. In our second example, we want to determine the x-intercepts of y equals x plus 4 multiplied by x minus 2. Again, you'll notice that the equation of this quadratic relation is in factored form, and we've also been given the graph of this quadratic relation. Therefore, we can easily figure out the x-intercepts by looking at the graph itself. So the x-intercepts are negative 4 and positive 2. I'm going to make a little label that is an x-intercept, and that is also an x-intercept. You'll notice something interesting. The value of negative 4 and positive 2 closely resembles these numbers, except the signs are the opposite. So there must be a mathematical way of figuring out these x-intercepts, and there is. I'm going to begin by rewriting my equation, which is y equals x plus 4 multiplied by x minus 2. To find the x-intercept, you're going to sub y equals 0. So I'm going to replace the variable of y with 0 in brackets. However, I do not need brackets, so I'm not going to write it in. So I have 0 equals x plus 4 multiplied by x minus 2. You'll notice that I've only changed one thing and everything else stays the same. This means when I multiply this binomial by this binomial, the answer is 0. That means one of these binomials have to be equal to 0, or both of them could be equal to 0. So I'm going to say x plus 4 is equal to 0, or x minus 2 is equal to 0. At this point, this should be pretty straightforward. You want to isolate your x, but it is stuck with positive 4. So you're going to do the opposite to both sides. You're going to subtract 4 from both sides. The 4's cancel out, and you're left with x is equal to 0 subtract 4, which is just negative 4. We're going to do the exact same thing to the other side. So I want to figure out what x is, but x is stuck with negative 2. Therefore, I'm going to do the opposite to both sides. So I'm going to add 2 to both sides. These 2's cancel out, and I'm left with x, and 0 plus 2 is just positive 2, but I'm not going to write in this sign. Therefore, my x-intercepts are negative 4 and positive 2. I already determined that earlier when I looked at the graph, and you can verify that for yourself. In the second part of our second example, we want to determine the y-intercept of the exact same parabola. If you've been given the graph of the parabola, you can look directly at it and determine the y-intercept to be negative 8. I'm just going to label it over here. However, if you're not given the graph of the parabola, you're going to have to do this mathematically. You're going to begin by rewriting the question, which is y equals x plus 4 multiplied by x minus 2. To find the y-intercept, you're going to sub x is equal to 0. Now, you're going to replace these values of x with 0 in brackets. However, I don't really need brackets, so I'm not going to use them here, which gives me 0 plus 4, and then 0 minus 2. And if we're using BEDMAS, we need to simplify whatever is in the brackets first. which leaves us positive 4 and negative 2. And next we're going to multiply. 4 multiplied by negative 2 is negative 8. And you'll notice that this value of the y-intercept matches up with what we determined from the graph. In our last example, we want to determine the x-intercepts of y equals 2x plus 1 multiplied by 3x minus 2. We've been given the graph of the parabola, so let's find the x-intercepts. They're over here, and I'm just going to label it. However, you'll notice that the values of these x-intercepts are very difficult to determine. They're somewhere in between 0 and negative 1 and 0 and 1. There must be an easier way of determining them instead of estimating, and there is. Use the exact same method as before, so let's begin by rewriting the question. Y equals 2x plus 1 and multiplied by 3x minus 2. We are going to sub y equals 0 to find the x-intercepts. That means we're going to replace the variable of y with 0, and everything else stays exactly the same. So what we have is a binomial multiplying another binomial, and the answer happens to be 0. Therefore, one of the binomials, or both of them, could be equal to 0. So I'm going to write 2x plus 1 is equal to 0, or 3x minus 2 is equal to 0. At this point, this should be pretty easy. You are going to isolate the variable of x. So here we have x, but x is stuck with this multiply by 2 and this plus 1. What you want to do is get rid of this plus 1. So we're going to do the opposite to both sides. We are going to subtract 1 from both sides. The 1's cancel out, which leaves us with 2x, and then 0 subtract 1 is negative 1. And we still want to get rid of this multiply by 2. The opposite of multiply by 2 is divide by 2. What you do to one side, you got to do to both sides. So those 2's cancel out, which leaves us with just x, and our answer is negative 1 over 2. If you were to convert this to a decimal, it would be approximately, or not approximately, exactly negative 0.5. And as you can see at the diagram, it is approximately negative 0.5. Do the exact same thing over with the other binomial. So we want to isolate x, but x is stuck with this multiply by 3, and it is stuck with this subtract 2. We want to get rid of the subtract 2 first, so we're going to add 2 to both sides of the equation. The 2's cancel out, which leaves us with 3x. 0 plus 2 is 2. We want to get rid of this multiply by 3, so we need to divide both sides by 3. Those 3's cancel out, which leaves us with an x equal to 2 over 3. And if you were to convert this to a decimal, it would be approximately 0.67. And if you take a look at the graph of the parabola, that x-intercept is approximately 0.67. So that's all the work you need to do to figure out the x-intercepts of this quadratic relation. In the second part of our last example, we want to determine the y-intercept of the same parabola. So let's take a look at the graph of the parabola. We can easily find the y-intercept, and it is right over here. It happens to be negative 2, but let's go ahead and label it. So there is a mathematical way of finding the y-intercept. We've already done it several times. Let's do it one last time. So we will begin by rewriting the question, which is y equals 2x plus 1 multiplied by 3x subtract 2. To find the y-intercept, we are going to sub x is equal to 0. Now, instead of writing the variable of x, you're going to replace it with 0 in brackets. And I'm going to actually write the brackets in this time. So I have y equals 2. I'm going to put the 0 in brackets. Everything else stays the same. I'm also going to put the 0 in brackets over here, and everything else stays the same. Don't forget to follow bed mass. So we want to do brackets, exponents, division, multiplication, and then addition and subtraction at the very end. That means we need to multiply these first. So 2 times 0 is 0, plus 1 stays the same. 3 times 0 is 0, and the minus 2 stays the same. Now, this should be pretty easy. Should be y equals positive 1, because 0 plus 1 is just positive 1, and 0 subtract 2 is just negative 2. Last but not least, you just need to multiply these two numbers. 1 multiplied by negative 2 is negative 2, which confirms our y-intercept value that we figured out by looking at the diagram.